Hello and welcome back to 2.2, Solving Compound Inequalities. Now we didn't have to cover this in 2.1 because everything we gave you was either a less than or a greater than, but I did want to hit on it before we started today, and that is if you have a less than or a greater than, it's an open circle, just like all the ones that we've been doing. But if there's an or equal to side to that, so a greater than or equal to or a less than or equal to, you need to have a closed circle because it's going to include the point at which you're at. Now, today we're going to deal with conjunctions, which is the same as your and statements, and your disjunctions, which are your ors. So with your ors, if it works for one or the other, and for the conjunction or and, it has to work in both of them. So here we have x is less than 2, and x is greater than or equal to 1. So when we go through and graph this, we 0, 1, 2, 3, 4. Okay. So what I'm going to do is I'm going to sketch each graph, and then we'll see where it covers. So we have x is less than 2, so that'd be an open circle at 2 with an arrow to the left. Okay, or we have x is greater than or equal to 1, so that would be a closed circle at 1 with an arrow to my right. Now, since we're talking about a conjunction, we need to know where it works for both of them. So where it works for both of them, right, is from here to here, right? But here it has to be an open circle. So we do an open circle at 2, a closed circle at 1, and then we connect the two together. Okay, for number 2, it's or, so it just has to work for one or the other. So negative 1, 0, 1, 2, 3. Okay, so x is a greater, or x is less than 0, it would be an open circle at 0 with an arrow to the left. X is greater than or equal to 1 would be a closed circle with an arrow to the right. Now, because it only has to work for one or the other, right? You can just literally bring these straight down, and this is your final graph. Okay, no intersection needed because with or it only has to work in one or the other. Okay, for question number 3, here, right, just like in equations where you have to, whatever you do to one side, you have to do to the other side. It's the same exact concept here, except now there are 3 sides. So whatever you do to one, you have to do to all 3. So if I want to subtract 5 away here to try and get my x by itself here, we get negative 2 is less than 2x, which is less than or equal to 10. Then to get rid of this 2, right, multiplication, to get rid of it we have to divide. So that means I'm going to divide everything by 2. And this is negative 1 is less than x, which is less than or equal to 5. Okay, now because this is already the and statement, this one works out really well because when you have the x in the middle, then you can just use your open circle, closed circle, and fill it in between. So negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Open circle at negative 1 because it's just a less than. Okay, closed circle at 5. And then we just simply fill in the in between. So open circle, I don't know why I filled that in after when I went back and redid it. Open circle over to the closed circle at 5. Okay. On to number 4. Okay, number 4 is more of the same exact idea, right? You have multiple things you have to deal with. You have all 3 different parts. So I'm going to subtract 3 from both sides. So negative 5 is less than or equal to negative x, which is less than 1. Now we have a negative x, so get rid of a negative x, right? We either have to multiply or divide by a negative 1. You can pick, it doesn't really matter. I'm just going to divide everything by a negative 1 just because it's the easiest way to do it. But now when we do that, that means we have to flip everything, right? So this becomes a negative 1 is less than x, which is less than or equal to 5. So notice how these signs all had to change, right? This had to go from a less than to a greater than. This had to go from a less than and equal to a greater than or equal to. So I just flipped the order of them. Okay, so the signs are still correct, right? 1 is less than, or negative 1 is less than x, which is what I have here. And then this x has to be less than or equal to 5. X is less than or equal to 5. Now we get the same exact thing we had on number 3. Like quite literally the same exact equation or the same exact solution set we end up with. So you just draw that out. Open circle at -1, closed circle at 5, fill in between. Make sure you leave your circle unfilled. Okay. Here we have an OR statement, so we solve each one independently of each other, and then we graph one each independently of each other. And then anywhere where it covers on either one is a solution to both. So we're going to subtract 7. -2y is less than or equal to -6. Divide both sides by a -2. Okay, and that's y is greater than or equal to negative divided by a negative is a +3. Okay, then we have the second side of this that we also have to solve. So we're going to get our y's on the same side. So I'll add y. I'm going to subtract 10. So this becomes 4y. Our 10's cancel each other out. 4 minus 10 is a -6. And then our y's cancel each other out. Okay, I then divide both sides by 4. And I get y is less than a -3/2. Now, I just went all the way to a -3/2 already, right? Because you can take 2 out of both the -6 and the 4, so that leaves you with the -3 and 2. So now at this point, when we want to graph this, okay, we have 3 in this -3/2, right? That's really the same as a -1.5. So if I start at like -2, -1, 0, 1, 2, 3, 4. Right, so x is greater, or y is greater than or equal to 3 would just be a closed circle with an arrow to the right. Okay, y is less than a -3/2, so that's about -1.5. So that would be an open circle and an arrow to the left. Now, because it's an or, if it works for either one, it works for both. So in this case, we can just bring that down onto our lower graph, and we're all set. No, I'm not going to pull out a ruler and measure if you're exactly halfway between the two for -3/2. Just do your best to make sure that it's, shows me clearly that it's in between the two. Okay, for number 6, same type of deal as the last one because it continues to be an OR statement. So we just want to solve for z on both sides. So add 1 to both sides. 2z is less than or equal to 6. Divide by 2, z is less than or equal to 3. On my other side, add 5 to both sides. 3z is less than or equal to 15. Divide both sides by 3, and you get z is less than or equal to 5. So now at this point, right, if I were to draw this out, so I need 2, 3, 4, 5, 6, 7. Z is less than or equal to 3 would be a closed circle here with an arrow to the left. Z is less than or equal to 5 would be a closed circle at 5 with an arrow to the left. Now remember, this is an OR statement, so it's either one of them. If it works for it, it works for both of them. So if we look at this top one for Z is less than or equal to 5, that actually covers everything that Z is less than or equal to 3 covers. So we really only have to bring the 1 down. So we can just simply bring down the closed circle at 5 with an arrow pointing to the left, and it actually covers all of that. So your actual solution to this is really just your Z is less than or equal to 5. That really covers them both. Okay, on to number 7. Okay, we have x is less than or equal to 0, and x is less than or equal to 3. So this and is what's really important here, right? Because it says and, so it has to work for both of them. So when we look at this, right, -1, 0, 1, 2, 3, 4. So x is less than or equal to 0 would be a closed circle at 0 with an arrow pointing to the left. Okay, and then x is less than or equal to 3 would be a closed circle here with an arrow pointing to the left. Okay, now it's an and statement, so it has to work for both. So you're only looking for things that work for both, which means here to the left works for both. So if we put a closed circle here, okay, at 0, and we put an arrow to the left, that actually shows us our answer. So our answer for this, when we go to graph it, is really just x is less than or equal to 0. Just like above, it was z is the less than or equal to 5. Here, it's the x is less than or equal to 0. Okay, number 8, again, we're at an and, so let's get this drawn in. So 2, 3, 4, 5, 6, 7. Okay, x is less than 3 would be an open circle here with an arrow to the left. X is greater than or equal to 5 would be a closed circle with an arrow to the right. And we're talking an and, right? So it's a conjunction, so it has to go with both of them. But we have nothing that goes with both of them. So the answer is just simply no solution. Okay, and there is nothing to graph because there's no solution. Okay, and then for number 9, it's an or statement. So it says x is greater than 0 or x is less than 2. So if I were to sketch this, right, my two different parts, so x is greater than 0 would be an open circle at 0 with an arrow pointing to the right. And then x is less than 2 would be an open circle at 2 with an arrow pointing to the left. Well, remember, this is a disjunction or an or statement, which means it only has to work for one or the other. So every single spot on this graph would work. So you just need to fill it in and darken the arrows on both sides. And then your answer would actually be all real numbers. Okay, or you could just write the R with the extra slash on it. Okay, so hopefully that was helpful to you. If you have any questions, please make sure that you contact me. Good luck on your homework tonight, guys.